Welcome to Let's Get Defensive, the show where we're going to see who has the best dad joke in a grueling competition that Andrew is probably going to refuse to participate in. Greg, start us off.
Well, that's a great idea. I'm pretty sure you're on the wrong show again. This is the new show.
Right. Did you know that folks used to use newspapers?
Really?
Like they got their news from newspapers. In fact, last night I was hanging out with a friend of mine, and he's got a son who, is he's probably 12, 13 now. And I asked him if he could hand me the newspaper, and he said, looked at me like I was insane. He's like, man, nobody uses those anymore. They get all the news off of tablets. And they just use tablets now. So that fly never stood a chance.
That's great.
What was the last thing that went through the fly's mind when it hit the windshield or the tablet?
We have to take a moment here. Andrew just made a joke.
Yeah,
I don't even know the punchline.
It's butt.
Yeah,
it's right. Butt. Okay. We all know it's butt.
All right. Welcome to Let's Get Defensive. This is the show where we've had a team of internet investigators scour the web to find interesting and current happenings in the world of aerospace and defense.
We're going to talk about those headlines as well and how they are or should be using the critical thread, i.e. the critical path along the digital thread to the hands of your customer and to optimize their road to profitability and successful product deliveries. We're going to have 10 amazing news items which we want to put on the table and talk about the challenges and how we go out fixing these product lifecycle challenges. And in between, we're going to take a couple of commercial breaks, fill you in with all of the other defense and space and a little bit of aviation news along the way. So a fun-filled show.
That's right. In case they aren't amazing, that's just because Andrew said they were going to be. None of the rest of us made the claim, so blame it all on Andrew.
Yeah. Yes. Yeah, I'll second that. Coming up, we've got Rheinmetall, U.S. Army and Air Force, General Atomics, Endural, Curtiss-Wright, Lockheed Martin, Mercury Systems, Kongsberg, NASA, Oshkosh, and quite a few others.
I guess we might as well just dive in.
Let's do it. Rheinmetall's Kyler Next Generation Armored Breaching Vehicle is a powerful machine designed to clear mines and obstacles. Man, that thing looks crazy. Quickly and safely. Using a heavy-duty rotor-powered mine flail system, it can clear paths for advancing troops. Demonstrated to military officials last month, the Kyler also features a massive mine plow and a rocket-assisted system for fast, wide breaching. Its versatility includes dozer capabilities and self-protection features. With potential for remote operation and further upgrades, it does showcase how advanced machinery can really streamline battlefield operations, which can be a matter of life or death, right? Potentially also.
Yeah, a lot of challenges with this
one.
Exciting product, I got to say. But how are they actually going to handle integrating all of these advanced systems, remote operations, mine flails, rocket assist, into a vehicle that is designed for extreme conditions? Bryan, I'm sure you've got problems on your mind, but to me, all of those systems in a single platform has got to be the biggest challenge in my mind.
You know, I am not going to brag, but I used to play Minesweeper in my younger days, so I think I'm pretty much an expert on talking about things that are going to get rid of mines. But no, honestly, this is impressive because one of the coolest things about it, I think, is the interchangeability of the functionality. You can quickly replace the mine plow with a dozer blade to get rid of tank obstacles or to fill in trenches or create emplacements. Like there's a lot of neat stuff that can happen with this. So it kind of feels like it might be the Swiss Army knife of vehicles on the battlefield. I mean, it's really neat. So the design that goes into that is really impressive because this isn't just Legos you can pop off and pop back on and say, let's go, right? I mean, this is durable, designed well. And so I think it's really cool. And it only takes, 2 people to operate it, they said, which is also fascinating. But they've done the demo, and now they've got to actually make a bunch of these because militaries are going to want to buy this. So I think that scaling, like how do you manufacture this kind of thing at scale, is going to be one of the more interesting challenges that I'd like to dive into. And of course, you've got to make sure that when you're manufacturing at scale, you do so with quality in mind. And as you mentioned, with the interchangeability or the integration in mind.
True. But But for me, you're dealing with heavy machinery in combat condition. It's not just about the functionality of all that. It's also about its long-term durability, ease of maintenance, and ensuring that everything works together seamlessly under pressure. So for me, it's about change and configuration management. I agree. Yeah, you've got the whole production thing, and I'm never shy of going into the manufacturing side of things. But for me, the biggest solution for this one is change and config management. You're going to need a solid process in place to track every system and upgrade, ensuring that the Kyler's flail system, the plow, the remote operation, all integrate smoothly. So with config management, you're ensuring that the changes, whether they're for maintenance or whether they're for upgrades, are going to be properly logged and compatible across the entire life cycle of that vehicle. But that being said, I got to add one more thing. I'm going to go back to that production site. Yeah, and not to miss a chance. The other big one for me is process planning and bill of process optimization. You know, using BOP optimization ensures that each subsystem of the Kyler ABV is produced and assembled efficiently as well. So I'm going to slightly extend into that manufacturing side of things as well.
You know, there was a commercial for some product. I forget. I remember these commercials where "Bop It" was like the tagline. So I think Andrew may have a new tagline for his. You just got to bop it. I don't know. Yeah. Before we go way too far off the rails, Greg, bring us into our next article here.
That's right. Speaking of remote operation, India is nearing a major $3.9 billion defense deal with the U.S. to purchase 31 MQ-9B Predator drones, which are manufactured by General Atomics. That is really a move aimed at boosting its military capabilities amid some growing concerns over Chinese activities in that region. These drones are really going to enhance India's reconnaissance and strike abilities, with 15 of them allocated to the Navy and the rest to the Army and the Air Force. This deal includes some components sourced from Indian companies, aligning with India's push to strengthen domestic defense manufacturing industry. And then, of course, you've also got the collaboration between India and the U.S. on advanced drone technology.
125 million. Is that what I saw just there? And it put up per drone.
125 million each. Yes.
Even with inflation numbers and cost of stuff going up, that still seems pretty impressive for a drone.
I'm not giving anything away, but right now we're in the middle of enabling manufacturing for a drone maker and military. I mean, you're looking at 15, 20 million. This thing is 125 million. That is a serious piece of kit. I'm wondering what it costs 100 and 110 million to do. So interesting.
I'm thinking it might be because the whole process isn't just the purchase of the drone, but this deal is also including the logistical support, the maintenance, the repair.
Right.
And
it's a long-term deal. Yeah.
That's a huge, you want these things. If I am spending, the pocket change of 125 million per drone, I want to make sure they last for at least a couple of weeks. Right. So you got to make sure that durability is there. So I think that for me, and it's got to be built in here, but the most important thing to look at is that aftermarket maintenance and possibly the training of, how do you go about it? Because sometimes you're saying, hey, I bought this thing, you keep it working for me. Other times you say, I bought this thing, now you're going to train me how to keep it working. And so, you got something different. Yeah.
My number one challenge on this one is integration of domestic Indian and US components into a unified drone system. Because with India sourcing components from both the US and domestic manufacturers, the key challenge is going to be integrating these components seamlessly into this Predator drone system. So balancing advanced US drone technology with locally manufactured parts is going to lead to some serious compatibility issues, in my opinion, production delays potentially, or inefficiencies in performance if you don't manage it all properly. So what do you got to get right? Change configuration management. That's got to be super tight. You've got to have that system in there. You're going to implement change config management to make sure all of these components are sourced from both US, India are properly aligned with the Predator systems. And that process then has to track every change, monitor compatibility, ensure that all your upgrades and modifications maintain the overall system performance. So for me, that's the challenge. That's the solution.
I want to toss in requirements management here too.
Yeah.
Because you've got,
I'll have change in config just slightly ahead of it though.
just because something works, in the US, now you're trying to implement it in a whole nother country. I mean, there's a lot to consider there. There's a lot to consider there.
Yep.
It's true.
All right,
We'll keep flying along with the advanced drone technology. Anduril has unveiled its new Barracuda series of air-breathing autonomous drones designed to tackle modern defense challenges. The Barracuda family, which resemble cruise missiles, include 3 different variants with different payloads and ranges, with the largest of those flying over 500 nautical miles. A key feature of these drones is really their adaptability, configurations for air, land, or sea launches. At one demonstration, Anduril showcased a voice-controlled drone that can execute commands autonomously, highlighting the potential for more human-machine collaboration in combat. It's exciting. I mean, the innovation here.
Yeah.
Production.
hold on here to the thought that you can shout, "Hey, Amazon," or was it Echo? I don't use that.
Alexa.
Alexa, thank you.
Or Bryan.
Yeah, while it's midair. I wonder if it operates from when you're in the ground. Hey, Alexa, don't hit me yet then. Anyways, big challenge here. You're introducing voice-controlled autonomous drones and multiple configurations across air, land, sea. How are they going to handle scaling production for such different launch methods and make sure that the drones work perfectly in all of these different environments? You got to say, Bryan, that's the #1 challenge.
I am shockingly just going to agree with you. I got to take a moment. Some folks may remember our weapon of the week we used to do.
Yeah.
This thing looks like it's a pretty strong contender. I mean,
I think you're right.
I think it's fair to say that this was also a pretty strong contender, but I think right now I'm going to go with the voice-controlled, hey, Anduril, blow shit up. Like, that's a pretty impressive thing.
That'll work. Yeah.
But we're dealing with was it air-breathing, autonomous. I think manufacturing scale is, as you said, #1. But something to keep in mind here is that
not a lot of MRO on this one, I guess.
The reason
coming back.
Yeah, the reason that Anduril is even trying to do this is because they said that the U.S. is currently not capable of producing the volume of weapons that we're going to need to establish deterrence against a peer competitor. So they say right now we can't manufacture at scale. So how are they tackling this? And this is interesting. They're looking at their supply chain and they're minimizing all of the defense specific materials and maximizing things that are commercially available components, which sounds like common sense and a great idea, but like it's going forward and saying, hey, we need to manufacture at scale. This is one way to look at it. Combine that with what I think Andrew is about to talk about, and you've got something that seems like it's going to be pretty darn successful. Yeah.
It's not just production. You've also got to kind of manage different kind of maintenance cycles, logistics, system updates for all of these variants. Obviously, you've not got a lot to maintain when you've let one go, but because they ain't coming back. But everything else to do with maintaining the quality of these as you go forward, logistics and these system updates. Not just one drone, it's a whole family of them, each with their unique challenges, in my opinion. So I'm going upstream on the critical thread. I'm going back to product structure and configuration management. You're going to need a clear structure in place that tracks the different variants of this Barracuda drone from a seamless design through production perspective. So that is good. There's no bumps, there's no silos, there's no manual systems. That's got to be digitally connected from design to production, because you got to produce that for air, land, sea, common components where possible, but it can be easily adapted for its unique environment. So for me, that's the solution.
And speaking of having a clear structure in place, our producers have just informed me that it's time for a commercial break. And we're back. Did you miss us?
I'm going for the Panzer Jaeger as weapon of the week, actually.
Oh, okay.
I saw that Rheinmetall was building another tank as well, not just the Kyler next generation, but man, they're busy.
We should take things from these massive tanks and talk about something a little smaller.
Yeah, just a little bit. Curtiss-Wright has introduced its PCM data acquisition system designed for high-speed flight test programs. This system really takes data, merges data from one or two IRIG 106 pulse code modulation streams at speeds
rolls right off the tongue there.
Yeah, just rolls right off the tongue. Yeah, speeds of up to 40 megabits per second, which doesn't sound fast, but also is extremely fast as you get to know these systems and the complexity here. I mean, its ability to packetize and integrate legacy PCM data into modern systems makes it ideal for fast jet, missile, eVTOL testing. Really supporting all these PCM line codes and data rates, this module is going to allow flight engineers to combine and process data efficiently, demonstrating how, I guess, these advancements in data acquisition are reshaping our aerospace testing and our manufacturing capabilities.
I think that's something, we've got stuff, all around us, right? Phones, microphones, computers. We've got technology everywhere. And I think at this point, we kind of take for granted and maybe even feel like that precision manufacturing is a solved problem, but it's everywhere. And it's the kind of thing where every cost savings that happens in it, every speed, every time you can save time, every time you can save money, everything just can really add up, especially because of the sheer scale at which a lot of these things are made, right? So there's always ways to improve speed and scale of manufacturing. And that's what I would be looking at because, obviously it's got to be quality. Obviously it's got to process everything fast, process the data efficiently. But one really interesting thing for me is that not only is this something that's, dealing with all those issues, it's also specifically going to open up a new world to help other product life cycles in different ways of testing and manufacturing in the aerospace and defense world. So this is cool.
I'm not one to disagree with anybody who says manufacturing is the biggest problem because, let's be honest, 1,000 times harder than design and engineering. So said the manufacturing person. For me, the number one challenge is going slightly upstream, and that's integration of your legacy and your modern data acquisition systems. Pause, reflect, move on. The reason being, the AXN PCM 401 system's ability to integrate that PCM data with modern systems is going to really give a significant challenge in maintaining compatibility, especially when it's so fast-paced, especially when you've got high-tech environments like jets and missiles, eVTOL testing. Ensuring all those legacy systems work seamlessly with your modern data system acquisition methods, for me, is absolutely crucial. So what do we do? How do we solve it? For me, it's requirements traceability. Curtiss-Wright can ensure that those legacy PCMs and codes are effectively aligned with modern data acquisition systems. So that requirements traceability is going to track each system requirement from legacy compatibility to new system integration, make sure all of those data streams are processed accurately and efficiently. There you go.
Greg, I think we need to take a moment here to pause, reflect, and move on.
Let's do it. The F-35 Lightning II has arrived at Marine Corps Air Station Cherry Point, which, for those of you who want some help with geography, that's on the East Coast, North Carolina, marks a big step for U.S. and European defense capabilities. It's now the first East Coast F-35 squadron to achieve operational capability, which really is going to be focused on conducting missions like close air support and electronic attacks. The cool thing about the F-35B is the short takeoff and vertical landing features that allow it to operate in these challenging environments. I mean, integrated with other F-35s globally, these aircraft can really share data, boost multi-domain operations, bolsters defense strategies from North America to Europe, really enhancing that interoperability. We talk about that a lot, but with NATO allies.
So yeah, absolutely. Biggest product lifecycle challenge, you might immediately say short takeoff, vertical landing, global data integration, all sounds wonderful. But how are they actually going to handle the long-term maintenance and data sharing between so many international partners? Bryan, for me, you got to agree that maintaining interoperability across multiple countries with different standards is the biggest issue.
It's definitely one of the biggest issues. So this is a really interesting landmark because they say one squadron is ready and 7 more are on the way. And achieving this initial operational capability basically means that there are now enough operational F-35B Lightning IIs, there are enough trained pilots, there are enough trained maintenance, enough support equipment to all self-sustain all the mission essential tasks. So this one squadron is ready to go and they've gotten it there, but they've got to get 7 more up in that point. So, you've already had your design, manufacture, training, and they're still building. Like all this stuff is happening. A lot of pieces have come together. And you have to consider that not only is this like, hey, let's get a plane flying. No, these things have that network enabled cooperative effort. They're going to basically work and function as a pack. So there's not only just, hey, this is manufactured and ready to use. It's also the training and how to use it and changing a lot of maybe conventional ways that pilots might even be used and maintenance might be used and everybody might be used to doing things. So I think there's a whole lot of stuff that goes into this being a product that is going to be used and be important. And so I think that the just innovation of all of those things together is really just the fascinating part about this. And I think there's maybe not just one most important portion for the critical thread here.
Yeah, true. But it's not just about the tech for me. It's about the life cycle management of an aircraft that's going to operate in so many different environments and with so many different systems. The F-35's good for you, Lockheed. Long-term success depends on how well they can manage all of these moving parts across different defense forces. So therefore, it's kind of coming up for the second time, I think, on the show, which is requirements traceability, but also global data integration. So you use your traceability, you ensure that the F-35B's capabilities, like the short takeoff, etc., aligned with the requirements of each defense force. On the data side, ensuring a seamless, secure global integration system is going to allow real-time sharing of mission-critical information across allied forces, keeping interoperability intact, and therefore the F-35B mission ready. So for me, requirements traceability and data integration solved.
Sold.
Mercury Systems has launched the DRF-4580L, which I know flows right off the tongue, but a small form factor digital signal processing module powered by Altera Agilex FPGAs. This cutting edge module is really detecting and processing electromagnetic emissions, simplifying radar, which is huge, communications and electronic warfare systems by really digitizing RF signals at the antenna. The technology eliminates the need for traditional signal conversion, reducing size, weight, and power consumption, making it perfect for defense and industrial applications. Now, Mercury's innovation really is enhancing these real-time processing capabilities. We're talking about going faster, further, and they're doing this in real time, really offering a more efficient, rugged solution for mission-critical operations.
Speaking of eliminating stuff, apparently on that slide we eliminated the need for a background, so that gave Greg a nice box head for a little bit there. That was great. But this, the idea of you're eliminating the analog signal down to all the conversion stages that are required by the legacy hardware by directly digitizing the radio frequency at the antenna. Like, this is an interesting concept because besides all the tech that it requires of the fast converters, the extremely fast converters, the high bandwidth, the data links, the real-time processing, but it's actually allowing to reduce all the downstream components and the processing time of those as well. So the integration with those legacy systems is going to be, I think, the biggest factor here. How are you communicating all of that? And I think this is the kind of thing that's going to be used a lot, which means, of course, manufacturing at scale.
Oh, okay. You curveballed me at the last minute there. I was going with that whole kind of direct digitization of the RF signals and the real-time processing as the number one challenge. I'm going to stick with that because your challenge really ensures that the direct digitization of RS signals at the antenna can be reliably implemented without compromising real-time processing speed. For me, that's the big one. So balancing that whole efficiency with ruggedization needed for your harsh environments while maintaining that whole performance. That's the issue. Solution for that, design and change management using DNCM, as we call it, because I had to introduce an acronym, ensures that your direct digitization technology and real-time processing are fully integrated into the overall system architecture. The approach, managing your updates, tracking design modifications, ensuring that the changes in the signal processing workflows maintain that system integrity and performance in these various environments. That's the problem. That's the solution. Yeah.
You mentioned bringing up an acronym. We haven't had a whole lot of acronyms yet this show, but also we haven't even had a whole lot of AI talks on this show yet.
Yeah, no, good thought. We know that AI is starting to take over, right? I mean, US and UK intelligence agencies are embracing generative AI to enhance intelligence operations. I mean, we knew that it was going to start taking over, but this is going to be interesting. I mean, they're going to be using AI for tasks like summarization, data analysis. I mean, they're going to be processing massive volumes of information more efficiently. This is probably going to be great for them. They also employ AI for red teaming their operations, which ensures secrecy, improves resilience. I mean, there's growing concerns about Russia and China's use of AI in military and disinformation campaigns. So the CIA and MI6 are really partnering with private companies to stay ahead in the AI-driven intelligence race. That's the best way to call it.
So the big one here is they are pushing generative AI to process huge amounts of data. But how do you scale this in this kind of AI technology while ensuring that it stays accurate, that it stays secure and manageable in such a sensitive area? Again, Bryan, wouldn't you agree with me that the balancing of the overall efficiency and security with something as unpredictable as AI is the real big challenge here?
I can neither confirm nor deny anything you've just said, because if I did, I might have to kill you.
Mm-hmm. Mm-hmm.
But if I were to say things, it sounds like it's official that AI is, in fact, spying on us.
Duh.
Which shows obviously something we already knew, but this is showing a lot of integration. You can't just say, hey, let's use AI. Let's type this into ChatGPT and suddenly it's implemented. Mm-hmm. There is a lot to think about with integrating into the software, into existing tech, into hardware, into processes, workflows. Mm-hmm. The need to plan even the requirements for how it's going to be used is just mind-blowing. And then the data storage it requires. I think there's a lot of stuff that you're going to have to consider as you go about scaling that AI and everything. There's so much. There's so much to go into this.
I mean, you touched on the tech stack there of an AI platform, which is something we're working on. But to me, it comes down to the fundamentals here, which is needing to scale that AI technology while maintaining total reliability, total data security, and operational control. That's the biggest issue. How do you fix that? To tackle that kind of a challenge of scaling AI while ensuring that accuracy, security, etc. There's not one solution. I'm going with three on this one. You've got to have data governance. You've got V&V, so verification, validation, and you've got to have change management, all within the critical thread. So first up, your data governance. You've got to implement robust data governance frameworks to ensure that all your data used by AI is secure, compliant. It hits those legal standards, and free from biases as well. Number one. Number two, your V&V stuff. So you've got to utilize rigorous verification validation processes to test those systems extensively before deployed. And that way you're including kind of stress testing the AI in simulated environments to identify any failures, any biases, security vulnerabilities. And then lastly, you're changing config management, applying change management practices to control these updates and modifications to AI systems. That's going to ensure that any changes are systematically evaluated, tested, and documented down the line, maintaining that integrity and reliability of AI over time. So sorry, guys, not just one solution in the critical thread, but we got a total of 3 there.
We have apparently been talking about AI and UK and US spies too much. Guys, we got to go for a commercial break. All right, so I used my voice-controlled Anduril to take out the Alexa that was trying to spy on me. So we're good now. We've survived.
There's another weapon of the week, that 6th gen fighter, huh?
It's true.
Yeah.
And it'll be cheaper, right? Cheaper than the F-35. And
Well,
I think
that's vertical takeoff, you say so.
that's very true. Yeah, that's it's great.
Probably.
Well, I don't know how expensive these are going to be, but Kongsberg's Hugin Endurance autonomous underwater vehicles have completed a groundbreaking, and when I say groundbreaking, it's more like sea-breaking, multi-week mission operating
underwater breaking.
Yeah, exactly. Fully autonomously with zero. Again, I say zero human interaction. It weighs 8 tons, stretches 40 feet. The AUV traverse depths between 50 and 3,400 meters, covering 1,200 nautical miles with a precision error of 0.02%. I mean, it utilized advanced sonar, cameras, laser profiling to survey areas efficiently. Really just kind of proving the capability that was built into it. Long range, shore-to-shore missions without the need for surface support. Impressive.
I think that it is very fair to say that we have now made Captain Nemo proud.
I would say that's accurate.
So here we've got we're in the design phase. We've reached the successful milestone. By we, this is the royal we, not the me we. But there's a successful milestone reached, which is that underwater braking that you're talking about here.
Yeah.
This is fascinating, fully autonomous. And I think it's fair to say that one of the biggest drivings for this entire process was the cost savings in removing the need for a surface ship. So being able to do all of this without having that surface ship support requires a lot of design and innovation, huge cost savings. And I think bringing us to the point of opening up entire new worlds. I mean, you know, you said this went up to 3,400 meters. The Titanic's only 400 meters more. So that's been something that's been very difficult for humans to reach. And of course, now if you don't have to have the humans to reach them, but you can make, there's a lot of cool stuff going on here. So for me, this is, you know, I think going back to quality, because if something goes wrong, you can't just dive down and fix it. So I think quality is going to be the most important factor here of what to consider. I mean, obviously the entire PLM process, but I think quality is the one that is my number one. Make sure the parts survive, function correctly, they've been tested correctly, so that your testing phases, your quality phases, your design and change all work together to make sure that you have a great product.
I think quality is a safe one because it kind of sits everywhere, doesn't it? Really, I mean, I can use quality on everything. I think it's used.
I feel attacked here, Greg.
Yeah. To me, it's autonomous operational efficiency and data management during long-term missions. That's the biggest challenge here. Ensuring that Hugin, AUV, thank you, whatever, fully autonomous missions while managing vast amounts of data collected by advanced sonar, cameras, laser profiling, maintaining performance without human interaction, especially across these depths and distances. It's going to require robust operational management. So for me, I think I'm going to do it again. It's a bunch of things that need to be in place. No room for error, long-term autonomy, data integrity and management, design optimization, all of those kind of things have got to be taken into consideration. So it's a quick one, but not really. Digital twin simulation, get that done. That's going to link you into verification and validation for testing under extreme pressure, stress testing of the structure and the components. But then it's QC/QA. So you need a good QMS. To your point, you need a good QMS, agreed. However, the other two things for me, supplier quality management. So you've got to ensure that all your materials and your components sourced from suppliers meet the highest quality standards. This is crucial because a single fault component could jeopardize the entire mission. Manufacturing quality control. And then lastly, I guess, documentation and traceability. Again, that maintaining the detailed records of all the components back into the design piece, manufacturing processes into manufacturing to trace any issues back to their source quickly. And then if I had another minute or two, I'd talk about predictive maintenance planning as well. But
what you didn't talk about was risk management.
Okay.
I mean, there's going to be giant squids attacking these things. How do you mitigate for that risk?
Should have seen a stupid thing coming like that, shouldn't I? Really? Yeah.
I feel like I have to side with Andrew on this one. I mean, I realize the importance of quality here, but if this thing implodes, there's no souls on board. So we got the data. Next up,
you're in HR, Greg. You want the people. Wait, there are no souls on board. This is automated, autonomous.
Yeah.
You'll probably have the unions walking out because they're not putting manpower on it as well.
Maybe. We'll see. NASA has awarded contracts to 8 companies to acquire Earth observation data, supporting the agency's Earth science research. Real quickly, I mean, these companies are all over the U.S. There's one in Canada, Black Sky Geospatial, ISI, MDA, Pixel Space, Planet Labs, Satellogic, Teledyne, of course, and then the Tomorrow companies. The commercial smallsat data acquisition program on Ramp 1 contract, which is valued up to $476 million, spans until November 2028, so for the next couple of years. Now, these firms will be providing critical data to enhance NASA's Earth monitoring capabilities, offering a pretty cost-effective way to augment existing observations. I mean, this is certainly going to help in improving environmental research and understanding of all of Earth's different systems. But what are the big challenges we're facing, especially with 8 different companies here?
Okay, so 8 different companies collecting and sharing off observation data.
Yeah.
But how do you manage the data standardization and integration across all of these sources? For me, that's it. So don't you think aligning all of this data into a cohesive system for NASA is probably the biggest challenge? For me, that is.
Yeah, I think we're in line here because that's, the amount of data being talked about here is massive.
Yep.
And just collecting the data is one thing, but actually making it usable is the other. So the integration of all these different sources of data, figuring out what are the requirements behind what I'm looking for, what I need, and of course, gathering other data because I might need it later too. And how do I archive it, use it, store it, transfer it, secure it, make it collaborative between all these different players. This is a task that is definitely something where computers are going to be involved, and probably AI in some way once you're looking at figuring out how to even sort, collect, and figure out what's happening with all of this.
Yep. So what's your solution?
The solution is to figure out your requirements management and what you're going to do with it. Because if I just say I want to collect it, it's not going to give me.
I agree with you, actually. I think I agree with you, unusually enough. But let me just precursor by saying, as we get into data standards, this is beyond my level of expertise. This whole data thing is another area of science and expertise beyond us. But I agree. It's all about requirements, traceability, and data standards. That's the two big things here. First up, you need a collaborative setup, i.e. a platform. That setup, you then coordinate your meetings, you get your V&V processes, including automated checks within the platform, manual reviews by NASA scientists, all those things. Then with that platform, you're into requirements traceability and data standards. So on the requirements traceability side of things, establish clear, detailed requirements that all 8 companies must adhere to, so that data formats, the quality metrics, the metadata standards, communication protocols, by getting those all lined up, NASA will ensure consistency and compatibility across all of those data sources. Then last, you need your data integration platform and your data governance. So your integration platform, utilizing robust data integration platforms or a middleware that can ingest, transform, and consolidate data from multiple sources in real time. And then, of course, the data governance framework. There you go.
Yeah, it sounds easy to say let's collect data, but there's just so much more to it.
So there's a whole bunch of standards and all sorts of things. Yeah.
All right, it is time for our last article, and guys, I gotta say I'm pretty excited about this one. The U.S. Postal Service, their new mail trucks, known as the Next Generation Delivery Vehicles, have started rolling out and are earning high praise from the carriers that are using them. There you go.
Wait. This is Aerospace and Defense news.
Yes, yeah. I'm sure you're wondering how did this article make it into a show about aerospace and defense? Well, this fleet was built by none other.
The ugly news.
None other than Oshkosh Defense. They are replacing the aging Grumman trucks that often broke down, even caught fire from time to time. I think I've seen a news article on that, but I haven't seen one, in person. I mean, I realize, and we saw the photo here, despite their unconventional design, these vehicles are really boasting some modern safety features, 360-degree cameras, airbags, and then some long overdue comforts like air conditioning.
Airbags and air conditioning, they're right on the cutting edge, aren't they?
Yes, they are. I mean, here's the thing, though. Speaking of cutting edge, most of the new fleet is going to be fully electric, which aligns with the Postal Service's sustainability efforts, right? They're looking to cut emissions by 40% by 2030. It's a big leap for both manufacturing efficiency that I'm sure they're carrying over into Oshkosh Defense is carrying over into their best practices into the defense projects as well.
Right.
So as just a brief recap, we started throughout the course of this show, we talked about the Minesweeper, crazy cool, interchangeable going in. We talked about the voice controlled attack drones. And now we are bringing you the discussion of the duck-billed postal vehicles.
Okay.
Yeah.
But I mean, I'm making fun of the way they look, but honestly, it actually is a really cool whole process here. And it is funny because one of the postal workers they interviewed for this said that you can tell the designers did not have appearance in mind.
Yeah.
I think it's a fair statement.
Yeah.
But it's showing that sometimes looks are not as important as other things, which is how I've survived as far as I have. But it's that you've got, the quality, the safety is actually huge, the functionality. So the older vehicles are actually prone to breaking down. In the last year, 100 of them caught fire. So maybe, there is time for change for new postal vehicles. They have been, some of them, in service since 1987, which to those of us who still mentally think we're in our 20s and haven't aged since then, that doesn't sound like that long ago. But 1987 is a long time ago. And they got a whopping, the originals, 9 miles per gallon.
Wow.
So it is time. I think this is an upgrade that's long overdue.
Yeah.
And they have been built with comfort, utility, safety in mind. But now, and I know that Andrew's going to say this is the easy way out here, they need 60,000 of these things. I think this is a clear case for looking at manufacturing at scale.
I totally agree with you. Exactly. As soon as you said 60,000 of them, that is me in agreement with you. The thought of mass production of full EVs for the USPS fleet, albeit from an Oshkosh who knows what they're doing, shifting to electric power, sustainability goals, all those kind of good things. I think the production scalability is the biggest challenge. However,
it was coming. We knew it was coming.
Slightly upstream from there, getting your process plans and your bill of process optimization is the first thing they've got to get right. That prepares you for production at scale. Oshkosh can streamline the production of the next gen delivery vehicle, NGDV, by optimizing manufacturing processes for scalability and efficiency. So they do that through virtual manufacturing. That's where I would come in. So it's almost like a digital twin process to the whole thing. That approach will support aligning manufacturing best practices with defense projects, ensuring that the company stays agile, both commercial and defense sectors, while maintaining sustainability and production goals. So there you go. I didn't go mess mom. I went just the notch before that.
You know, it does seem like we're now possibly giving a new meaning to the term going postal. It could now mean actually like being safer, better quality, more efficient, instead of previous meanings of the term. I'm trying here, but no, I think this is, you're right, Andrew.
Now, here's a question. Do you think this new generation is going to last longer or shorter than the previous generation?
Probably shorter. I think technology keeps advancing fast enough. And there is questions about that. You said all electric, right? I mean, some of these batteries don't last as long, to be honest, as, you know, old school diesel engines, right? And it's what happens to they operate in the cold as well. Is the phrase of, you know, what is it? Snow, ice. I forget the whole motto of the Postal Service, but will they be affected by cold weather?
Yeah,
that's the thing that happens.
There's plenty of EVs driving around in Canada and Denver and places like that. No problem.
Denver's the cold weather in Andrew's mind.
Pretty soon they'll have drones delivering mail, so I wouldn't be surprised.
So everybody, thanks for joining us for this recap of 10 hopefully interesting news articles that happened in the aerospace and defense, and our takes on how proper product lifecycle management, viewing of the critical thread, can help affect what's happening with production, profitability, all of these things. And with that, we'll see you all next week on the same bat time, same bat channel.
That's right.
Sounds good. See you next week. Good week.
See you next week.